Okay, part B, we're asked to find and interpret the marginal productivity of capital when x is 1, y is 8. So the formula for the marginal productivity of capital is just like any marginal back in Calc 1. We're taking the derivative of the quantity q. In this case, since we want capital, we're taking it with respect to y. And so we have 300 x to the 1/3. These are the constants. We take the derivative with respect to y. We get 2/3 y to the minus 1/3. I simplify. I get 200 x to the 1/3 y to the minus 1/3. So qy at 1, 8. I substitute x equals 1, y equals 8. 1 to any power is 1. 8 to the negative 1/3 is 1 over 8 to the 1/3. The third power on 8 is the cube root of 8, so I get 200 over 2, which is 100. So the marginal productivity of capital is qy at 1/8, and that's 100. So how do we interpret this now? Well, marginals, the way you interpret marginals is instead of writing it as a rate, what you do is that if you go one more in the independent variable, so in other words, if we increase y by 1, then the increase in the dependent variable, in this case q, is going to be roughly that amount. So we interpret the 1 and the 8. So when $100,000 is spent on labor and $8 million is spent on capital, if an additional $1 million were invested in capital. So that's the idea. We're increasing y by 1. If we increase y by 1, the quantity of autos produced would be approximately, would increase because we have a positive 100, would increase by approximately well 100, but 100 corresponds to 100,000 autos. So instead of interpreting this as 100,000 autos per $1 million, which is how we would interpret it as a rate, we take that rate and multiply it by 1 unit of the independent variable. And so it says for an additional $1 million, we're going to get an increase of production of roughly 100,000 autos. And that'll do it then for part B.